Alright, I'm going to record this twice, doing two different ways. The first way I'm going to look at this is using the rejection region as my solution. And then in the second one I'm going to record it, I'm going to use p-values to compare. In both cases, I'm going to use the calculator as my main tool. And we'll look at how the calculator gives us different values. You can still find p-values and critical values using the tables. Again, page 369 in the book in the lower left down there has a great little chart of common levels of significance and what their critical value will be, or their value of the border, the region, our test value. So we're going to look at this problem, and we're going to set it up so that we can do this with a rejection region. So the first thing I'm going to do is draw it out. So a researcher claims that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. So our claim is coming there. Let me just do some switching back and forth here. What I want to do right now is we have a proportion. That proportion, whoops, let me make sure I get a color. I'm in a blue mood today, we'll do blue. Some proportion is less than 0.45. Actually, let me give some space here. That's the claim the researcher is making. Right? The proportion is less than 0.45, so that'll be the claim. Automatically, when we're given P, we know Q, because Q is the complement of P, so I'm just going to put this over on the side, that this is the boundary of 0.45, and so complement's 0.55, something we know. And this is going to be the alternative hypothesis, because it does not have the equal sign. So I know my null hypothesis, I'm going to flip that and give it the equal sign. And so we have now put this into hypothesis realm. Okay, let's go back and read some more of it so we can compare it. Just the claim is hanging out there nice and neat. We want to see what that claim says. So we want to test this claim. And so we want to see if there's enough evidence to support that claim. So to do that, we have to do an experiment. So in a random sample of 100 adults, the proportion I get is 41%. That say their passwords are less secure because complicated ones are too hard to remember. At a significance level of 1%, making type 1 errors less than 1%, is there enough evidence to support the researcher's claim? So there's a claim being made that it's less than 45%. We want to test that claim. We run an experiment, and we want to see if the evidence supports that claim or not. So that's the game here we're doing, right? We're not saying the claim is true or false. We just want to see if the evidence supports the claim or not. And the only thing we can test is the null hypothesis. So we do have everything we need here. We ran an experiment with 100 people, and our test proportion, what we got from our experiment was 0.41. So if I look at my alternative hypothesis, it's pointing to the left. So this is a left-tailed test. So I'll come over here and just give an idea of what my rejection regions are going to look like. Let's see. I think I'll continue to use light blue for this. Okay, there's my beautifully drawn normal curve. Being a left-tailed test, alpha is going to be there. And we have alpha having a value of 0.01. So the probability of landing in this region is 1%. That's what alpha is saying. And so that's my rejection region. If my test data falls in here, I reject the null hypothesis. And if my test data lies in here, I fail to reject the null. Alright, so we need to turn this into a Z value. If we look on the chart on 369 and we go down in the bottom corner there and we look at a left-tailed test, that critical value, a left-tailed test with an alpha of 0.01, we get a critical value of Z naught. I'll probably put ZCs on there here. I don't know why the book goes Z naught and ZC between two different types. I tend to critical values get a C. I'm trying to keep consistent with the book. And so this line right here is at Z equals negative 2.33. So I will test my experiment against that, and I'll see where my point lies. So my test value is my experimental proportion minus the one claimed in the null. We'll assume the null's equality. We always assume P equals whatever the null says, right? We assume the null is true, and the equality part of the null is true. That gives us a test. Oops, sorry, I should finish my equation here. And the square root of P times Q divided by N. So in this case, make sure, for me, that's going to be 0.41 minus 0.45 divided by the square root of 0.45 times 0.55 divided by 100. And I'll do this in the calculator. Some things to note: square roots will always be positive. And so this is going to be negative. So I'm definitely going to be, my test value is somewhere with it on this side of the P value stated. That's the nature of these problems. Whenever we see square roots down here, this will always be positive. And so the sign of the difference is going to tell me where I am here. That can be helpful sometimes, but I'm just getting a feel for this. All right, let's pop over to our calculator here. Let's see, where's my calculator? There it is. And you're seeing the calculator here. I do apologize that I don't have a way of showing both together. I might have a solution to that someday as I learn these new softwares. So I'm going to clear my memory. So I'm going to put the numerator in parentheses. So negative 0.41 minus 0.45. That's everything upstairs, and then everything downstairs. It's not a bad habit to put everything downstairs in parentheses. And that's the square root of 0.45 times 0.55 divided by 100. Come out of the square root and my parenthesis. And I get a z-score of negative 0.804. Well, we'll do 4 decimal places. Negative 0.8040. Here. It's a negative 0.8040. Well, that's somewhere in here, right? It's bigger than negative 2.33, but it's less than 0, so it's in this region, which is the fail to reject the null hypothesis. So I can't reject this, which means I don't have enough evidence to move to here. And since the claim is the alternative, we say I don't have enough evidence to support the claim. I'm going to do this with p-values in the next video.